Hi, I'm Craig Rowland, founder of Sandfly Security. Today we're going to talk about old and obsolete password hashes on the Linux operating system. Now, Linux has had a variety of password hashes over the years that are designed to protect users' passwords from being easily stolen and used. Basically, when you type your password in, it is passed through an algorithm that mixes it up in a cryptographically viable way and then writes it out as a hash into a file so that if that file is stolen by the attacker, they can't easily figure out what the user's password is. They actually have to run through a variety of work to reverse that algorithm to figure out what the user might be using. Now, this is all well and good, but the problem is over the years, CPUs have gotten faster and the new GPUs that are out are phenomenally fast. And this means that they are very well suited to doing brute force attacks against user passwords and in particular, obsolete cryptographic hashes. So now when a hash is stolen, a modern password cracker could do millions or even billions of attempts a second against that password. And if you know most users, they're very bad at picking a password. So it's very easy for these computer systems to very quickly run through all the iterations and find out what they're doing. Even if they pick a random password, if it's below a certain length, chances are very high that system might be able to crack it, especially with a legacy algorithm. The other problem with legacy algorithms on Linux is that they frequently are indicating smoke. And where there's smoke, there's fire. And what I mean by that are these old algorithms are typically found only being used on legacy systems. So if you see an old password algorithm, that typically means it's a very old system. If it's a very old system, that means it might not be patched. It might not be upgraded. It might have server configuration issues or things that are going to cause it to get compromised. That's going to allow an attacker onto there going to allow those attackers to steal those passwords, crack those passwords, and then use them for lateral movement across your network. So the whole thing is very bad news. The other thing that it does indicate is that it might be an old password or an old user account that was moved onto a modern system. Now, that's fine because a lot of the password algorithms are backwards compatible, but where it's not fine is the fact that if they're using a password algorithm hashing that old, that user has not changed that password in a very, very, very long time. And again, if that password is ever compromised on a legacy system, that means an attacker is going to have immediate access to your modern system. So in any event, the user needs to update that password and use a modern hashing algorithm. So let me show you how all this looks. I'm going to go over to the Sandfly dashboard here. Now, Sandfly is an agentless endpoint detection response system on Linux, but we also do a lot of other cool things, such as being able to look for policy and security mismanagement, SSH keys for lateral movement attacks, and passwords, which I'm going to show you here in a moment. So we scan one of our systems here, and on that system, we got a couple of alerts. The first alert we got is we have a policy alert that indicates that a user here called Jack Slack has a problem. And the user here, Jack Slack, is using an obsolete MD5 hash for their password. I can see here who they are, their group membership. I can see here that yes, indeed, they do in fact have a weak password hash type. So I know that this user, Jack Slack, is either a very old account or that this system is very old. The next problem that we found in this system, which frequently goes hand in hand with legacy passwords, is that there was just a bad password in general. We looked at this box and again, we found our user Jack Slack, and Jack Slack has a password that's the same as their username. It's one of these things we tend to see over time that using these legacy password hashes are frequently tied to accounts that are mismanaged or that are just very, very old. People aren't paying attention to them anymore, or maybe they were carelessly credentialed when they were first created. But in this case here, we found that this account has a password that's the same as a username. We can run through custom password lists to find this kind of activity, no problem. But again, they tend to go hand in hand, these types of problems. Now, how does this look from the terminal side? If I go to my terminal over here and I cat out Etsy Shadow, we're going to see here a couple things. I have two users with passwords, and that's this long convoluted string here. The first user is called Pi because this is a Raspberry Pi, and the prefix for the password is $Y$. That means YesCrypt. This is a modern algorithm. YesCrypt is designed specifically to be very slow to execute, even on specialized hardware. It's hardened against those types of attacks, and even GPUs do not perform very well when doing a lot of brute force attacks against that algorithm. But down here we have Jack Slack. His account starts with a prefix of $1. And what this means is that this is an older MD5 hash. These MD5 hashes are very easily optimized for password cracking on modern systems. So you don't want to see that anywhere. But basically here you can kind of see the two problems here. And again, what I would say here is because we have YesCrypt up here and because we have MD5 down here, this again was probably a legacy account that was moved onto a modern box. But either way, it needs to be investigated. So in general, what I would tell you is essentially you should pay attention to this type of thing. If you see legacy passwords lying about, those systems are typically legacy or they need to be looked into. That's something we can give visibility into, but also it indicates that you have a very high likelihood of an attacker is going to get lateral movement to those accounts if they steal those hashes, because the chance of them pulling off a brute force attack are very, very, very high against the obsolete password hashes. And you should try to work very hard to get them out of your enterprise if you're still using them. So I am Craig Rowland from Sandfly Security. Thank you so much for watching my video. Check out our other videos for more short Linux security, forensics, and intrusion detection topics. I appreciate your time today. Thanks again, and bye.